communication system. It is a process of sending information signal from one point to another point which involves transmitting, receiving and processing. I believe you all heard about modulation before. But do you know what modulation is? During modulation process, the message signal modulates the carrier to produce the transmitted signal, modulated signal, at high frequency. Modulation is needed especially in long-distance signal transmission. Do you know that? We have two types of modulation which are analog and digital. What is analog modulation? It is a process of transmitting an analog wave, low-frequency, signal, such as audio or TV signal over a higher frequency signal such as a radio frequency band. Under analog modulation, it is further divided into amplitude, frequency and phase modulation. First, we look at the amplitude modulation. It is the fundamental modulation process in communication system. We can see three waveforms here. The first waveform is carrier signal and the second one is the modulating signal. We can notice that carrier signal has the higher frequency than modulating signal. As mentioned just now, during modulation process, the message signal modulates the carrier to produce the transmitted signal, modulated signal, at high frequency. The last graph is the modulated signal. From the signal, it forms envelope, and the amplitude of the signal is limited by the envelope. In frequency modulation, the modulated signal will have higher frequency wave at the instant of the peak of modulating signal. For phase modulation, the modulated signal has the highest frequency wave during the rising edge of modulating signal. Next, we look at the digital modulation. It is the process of encoding a digital information signal into the amplitude, phase, or frequency of the transmitted signal. Same as analog modulation, digital modulation contributes to three types of phase keying, which are amplitude, frequency and phase shift keying. The modulation technique between analog and digital are the same, the only difference is that the modulating signal now is a digital signal. At here, the digital signal is applied to switch the carrier amplitude, either high or low. We can get the signal at modulated signal only when digital signal is on. In other words, switch high. In frequency shift keying, we can obtain a high frequency waveform when the digital signal is switch high. In phase shift keying, changing an amplitude of digital signal indicates there is a 180-degree phase shift in the modulated signal. These are about the modulation. For demodulation, it did the same as the modulation but in another way round. It will do back what we do during modulation process. In phase shift keying, there are two common examples, which are binary phase shift keying and quadrature phase shift keying. Before we go further into BPSK and QPSK, let's introduce the term symbol and symbol rate. Symbol is final representation before transmitted through physical medium. For example, amplitude, frequency and phase. Symbol rate or baud rate refers to the number of symbols transmitted per second. In fact, the maximum rate for a signal to be transmitted reliably through a PSTN voice channel is 2400 bauds. Next, let me introduce BPSK. With BPSK modulation, a carrier can only transmit one bit of information at once. The carrier undergoes two changes in phase, which can be represented by two symbols. One symbol represents one bit. Two different symbols can be represented by 0 and 1. The phase will vary from 0 degrees to 180 degrees depending on the digital signal. Next, QPSK. For QPSK modulation, a carrier can transmit 2 bits of information at once, instead of 1. This effectively doubles the data to be carried by a signal within the same bandwidth. The carrier undergoes 4 changes in phase, which can be represented by 4 symbols. 4 different symbols can be represented by 4 combinations of 2 bits, 00, 01, 11, and 10. The phase will vary from 0 degrees to 360 degrees. The most common carrier phase shift for QPSK is 90 degrees. QPSK changes from 45 degrees, 135 degrees, 225 degrees to 315 degrees. In short, QPSK is actually two BPSK system that has a 90 degrees phase shift between them.
Okay, this part is about quadrature amplitude modulation. Let's discuss about quadrature amplitude modulation. So, we denote this quadrature amplitude modulation as QAM in our discussion. So, what is QM? QM is the method of combining two amplitude modulation signals into a single channel. So, why this QM is introduced? Actually, because it wants to double its effective bandwidth. But how this QM work? So actually, this QM method is utilizing both amplitude and phase components to provide a form of modulation. So the principle is this QM both has same frequency but differ in phase by 90 degrees. So there are many types of QM format. For example, we have 16QM, 8QM, 12QM, 32, 48. and even 256 qm. So we can see here, let's say we take 16 qm. So y-axis as a q, which is quadrature on vertical axis, and I is on x-axis, which is in phase. So it can be seen that from this few qm diagram, if the modulation order increase, the distance between the points on the constellation also decrease. So accordingly, small amounts of noise can cause greater issues. As the level of noise increase due to low signal strength, so the area covered by a point of constellation increase. If it become too large, then the receiver is unable to determine which position on the constellation the transmitted signal was meant to be, and this result in errors. So it's also found that the higher the order of the modulation for the QM signal, the greater the amount of the amplitude variation is present on the transmitted signal. So for transmitter RF amplifier, which is for everything from Wi-Fi to cellular or more, it means that linear amplifiers are required. So in our domestic use, for domestic broadcast, 64 qm and 256 qm are used in digital cable television and cable modem.
Next, let's move on to the advantages of QAM. One of the significant advantages of QAM is its ability to efficiently use available bandwidth. In traditional communication systems, we use simple modulation schemes like amplitude modulation or frequency modulation. However, these methods occupy larger chunks of the frequency spectrum. QAM, on the other hand, allows us to transmit more data in the same bandwidth by encoding information in both amplitude and phase. This means we can send more bits per symbol, making communication more data efficient. Another key advantage of QAM is its robustness in noisy environments. As signals travel through different mediums, they often encounter interference and noise. QAM's ability to encode information in both amplitude and phase provides a higher level of resilience against such disturbance. By using a combination of amplitude and phase, QAM enables the receiver to distinguish between different signal states more effectively, even in the presence of noise, ensuring reliable data transmission. QAM allows for higher data rates compared to simpler modulation techniques. As technology evolves and the demand for faster data transmission increases, the versatility of QAM becomes crucial. With QAM, we can achieve higher data rates without requiring additional bandwidth. This makes it an ideal choice for applications such as broadband internet, digital television, and wireless communication. Lastly, QAM enjoys widespread support in modern communication hardware. Its adoption is prevalent in various devices, including modems, routers, and communication chips. This compatibility simplifies the integration of QAM in existing infrastructure, making it a cost-effective and readily deployable technology. In simple terms, data transmission is a process of sending and receiving information between devices. This figure shows a simple example of data transmission from computer to terminal through telephone network. Dumb terminal is a terminal that does not perform local information process. It serves as an input or output device. Modem is a device or program that allows computer to transmit data. It allows terminals to connect to computer over telephone network. Lastly, the telephone network is used to provide voice communication. It carries mostly voice with SAM data, consisting of primarily of modem linked computer and facsimile.
Next, 5G. What is 5G? 5G refers to the fifth generation cellular network technology. How 5G benefit and impact society, economy, health and industry. Second, economy. NIHS market study estimate that 13.2 trillion in global economic value will be made possible by 2035, generating 22.3 million jobs in the 5G global value chain alone.
Since 5G enables faster and high quality communication at magnitude scale, so in terms of health, mobile health, and the wider introduction of telemedicine result in increased accessibility to quality healthcare. In terms of industry, remote maintenance and remote routine is possible to do since we have 5G, and it can lead to lower operational costs, such as overhead costs in the office. So in terms of transportation, so since 5G can make self-driving trucks, it can reduce the number of drivers since everyone can control the car and truck at the office. So it can reduce the number of drivers needed and also reduce the fatalities rate of driving. So the misconception of 5G. So many people make a lot of bad assumption for 5G itself. So first and foremost, the electromagnetic field generated by 5G reduced cognitive function. A small 2018 research review concluded that there is no solid link between EMFs and cognitive concern. So second, the assumption by people is electromagnetic field generated by 5G can cause cancer. A 2018 study did not find a clear association between high frequency EMFs and brain tumor. So lastly, 5G is more exposed to data breach. 5G builds in support for a zero trust approach to data access, which can lock out the intruders and cannot hard to access the data, user data. Thank you.